So, what if one of the biggest secrets in physics wasn't some new discovery, but was actually hiding in plain sight for, get this, over 150 years? Today, we're diving into a quantum puzzle that was solved by looking backward, not forward.
You know, for decades, physicists have been on this quest to find the complete rule book for a single particle of light. But what if it wasn't a new discovery at all? What if the answer was written down way back in the 1860s, and we just didn't realize what we were looking at? Okay, so our story today is all about the photon, the fundamental particle of light. It's the reason you can even see me right now, the reason your radio works. It is literally everywhere. And yet, for something so important, it's been at the heart of this huge, nagging quantum puzzle. So before we jump to the big reveal, we really need to get why the photon has been such a massive headache for physicists for, almost 100 years.
All right, to put this in perspective, think about the electron. For the electron, physicists have this beautiful, clear set of rules, the Schrödinger equation. It's like the perfect instruction manual. But for the photon, man, its rulebook has always been a total mess, just scattered, incomplete, and full of things that just don't make sense.
And this isn't some new thing, For almost a century, finding a complete working theory for just a single photon has been one of the holy grails of physics. But every single time someone tried, they just slammed into the same impossible walls.
So what were these walls, these roadblocks? Well, it basically boils down to three major hurdles that kept the photon's secrets totally locked away.
Okay, roadblock number one, the position problem. So in quantum mechanics, to find a particle, you need a special mathematical tool called an operator. But for the photon, this tool was, it was broken. You couldn't use it to find the photon's x, y, and z coordinates at the same time. It's like, imagine you're trying to measure a box. Every time you measure its length perfectly, the measurements for its width and height just go all blurry and uncertain. It's a complete paradox.
All right, next up, we have the probability problem. A probability map is supposed to tell you the odds of finding a particle in a certain spot. And probabilities are simple, right? They can be 50%, 10%, 0%, but they can never be negative. It's just not a thing. But the standard formulas for the photon, they could spit out negative probabilities. That's not just weird, it's completely nonsensical. It's like saying there's a negative 20% chance of rain.
And then there's maybe the weirdest, most mind-bending problem of all, the causality problem. We all know the biggest rule in the universe, right? Nothing travels faster than light, but the existing theories for the photon, they broke that rule. The math predicted that if you could somehow perfectly pinpoint a photon's location, it would instantly have a non-zero chance of being found literally anywhere else in the universe at the same time. That's not just faster than light, it's instantaneous communication across the cosmos, a total violation of causality.
So you've got these three massive, seemingly impossible hurdles. The whole problem just looked completely unsolvable. It really felt like physics was going to need some brand new radical theory to fix it, or maybe not.
See, the breakthrough, when it finally came, didn't come from some crazy, complex new math that tore up the old textbooks.
Nope, it came from going back, like way back, all the way to the classical theory of light and electricity, the one laid out by James Clerk Maxwell over 150 years ago.
The whole game changed in 2019. A physicist named Margaret Hawton published this paper with a pretty revolutionary idea. She basically said, hey, we don't need to throw out Maxwell's classic equations for light, we just need to extend them. Her argument was that the full quantum theory for the photon was actually there the whole time, just kind of hidden inside the classical physics we already knew.
So how on earth did one paper crack a problem that was a century old? Well, it came down to three really clever insights that finally unlocked the code. Okay, first, to fix that crazy causality problem, the theory uses the entire classical light field, both the positive and negative frequency parts, not just a piece of it. It sounds technical, but this one change makes sure the photon behaves properly, preventing that impossible instantaneous spreading. Done. Second, to fix the probability problem, the theory comes up with a new way to calculate probability that by its very definition is always positive, so no more negative probabilities. And what's really cool is, once you solve those first two problems, the position problem just disappears. A proper working tool to find the photon's location just naturally pops out of the math. It all just clicks into place.
And this quote from the paper itself really says it all. The idea isn't to trash the old theory, but to inherit everything from it, all the math, all the ideas, and just build on it.
It shows that the quantum world and the classical world aren't these two totally separate things. They're actually deeply, deeply connected.
So, in the end, Maxwell's equations were never wrong. Not at all. They were just incomplete. They were the perfect foundation, just waiting for someone to come along and add the missing quantum layers right on top.
And that brings us to the really big picture here. What does it actually mean that this huge secret was just sitting there, waiting this whole time?
Well, for starters, it means a consistent, logical quantum theory for a single photon is finally possible. That's huge. It also suggests that this hard line we always draw between the weird quantum world and our normal classical world, well, maybe for light, that line is just an illusion. And maybe the most amazing part? It basically makes James Clerk Maxwell an accidental quantum pioneer. He laid the groundwork for a quantum theory of light like 50 years before quantum mechanics was even a thing.
I mean, just think about that for a second. The exact same set of equations that describes everything from the radio waves hitting your car to the most powerful gamma rays in the universe already had the quantum secret of its own particle written right into its DNA.
And that just leaves you wondering, doesn't it? If a secret this huge could be hiding in a theory that's 150 years old, what other revolutionary secrets are out there, waiting to be found, not in some bizarre new frontier, but right inside the physics we thought we already knew inside and out?